When I was in fifth grade, I had my middle school math teacher, Mr. Leffler. He taught us this trick called casting out nines. Thought it was the coolest thing ever. It was completely magical. And then it wasn't until I was taking this exact class in college that I realized how did casting out nines even work. So when you're in middle school, this is when you first start to learn how to multiply large numbers like this. So this would be the type of problem that maybe you start to do as an advanced fifth grader, and you're like, okay, it's great. So I multiply this down. This is the classic way of doing it. But I just multiply the 3 times the 2, I get the 6, and all of this stuff. And so this is what you may see. So the trick about casting out nines was that I was told you want to take a look at this number, this first number, and you want to cast out nines. But what that means is you add up the digits, and then any copies of 9, you're just going to subtract them until you get a number between 0 and 9. So here, if I add up these digits, I'm going to get 10 plus 3 gives me 13. When I cast out a 9, or subtract off a 9, I'm left with a 4. I do the same thing here. I add these two together and I get 6. And I do this with my final answer here. So I take 9 plus 0 plus 1 plus 6 plus 6. Now, once you got a little faster, you realize, oh, I could just start subtracting out 9s immediately, right? So anytime there's a group of 9, get rid of that. Here, then I'm left with a 13. So that gives me 13. Okay, what is that? Mod 9, that's going to be 4. Okay, now also the other trick that I was taught with this is, let's say if you did get to a number like 13, again, you could subtract out copies of 9, or you could just add the digits together, and then that would just give you the magical answer. So all of this to my little fifth grade brain was like, well, I don't know what's going on, but then to check your answer, you would multiply these two. So this was a multiplication problem. You would multiply these two numbers together, and you would get 24. You would do the casting out 9s, which you could subtract off copies of 9, or once you got a hang of the other trick, you just add these two digits together, and this would give you 6. Now, this answer should match with this answer. If it doesn't, that means you made a mistake. So here, I'm like, oh, wait, this doesn't match. I need to go back and I need to check my answer. So if I go back and I say, okay, where did my mistake arise here? So I look, okay, 6, here, 14, 2, I'll carry the 1. Oh, no, there's supposed to be a 3. And then if I check the next line, I have the 2, I have this. Over here, oh, no, this was supposed to be a 6. So now if I redo this, this should become a 2. And then this, when I carry the 1 over, this should be a 1. Now, when I redo casting out 9s again, I get the same information over here. When I multiplied all of this, I got 6. Now over here, when I do the casting out 9s, I have a 9, 6, 2, and a 1. That's another 9. I'm left with a 6. So now I see that these two match, and so that was my correct answer. So once you got the hang of this, this was really cool, is that you could always check your answer. Now, this only worked as long as you were off by a slight mistake. If you really butchered all of this, then yes, we could make this not work. So we learned this for multiplication, and we also did the same thing for adding, where if you had, say, 2, 4, 7, 3 plus 7, 9, 1, 0, if you add these together, we would do the same exact thing. And instead, though, whatever this would be when you cast out 9s, this would be 7, and this would be 8. When you add these together, because you're adding instead of multiplying, you would get 15. You add the digits, and you get 6. So your answer over here should also be 6 when you're doing casting out 9s. So all that being said, as a fifth grader, I learned this. And then when I learned about modular arithmetic, all you're doing is that you're looking at these numbers modulo 9. So this number, mod 9, we see is going to be equal to, this one was 6 or 4. And we see this one, mod 9, is going to be equal to 6. When you multiply two numbers, mod 9, you can then reduce that mod 9, and you get 6. So these two numbers, when you multiply them, should give you 6 mod 9, because that's just the way modular arithmetic's working. So all I learned back in 5th grade was this trick that you can do with modular arithmetic mod 9 to be able to check your answer for these types of multiplying and adding. So this is just a really cool trick that obviously stuck with me throughout the years, and I think it's a really fun one that if you do teach kids in the future to have them see this and then all of a sudden have their minds be blown. And then if they're advanced enough, you could discuss with them the idea of modular arithmetic.